All right. So my screen's visible, right?
Ja, all good.
Cool. So I'll start with introducing my colleague Ernest, who's a Concordium Rust advocate. And I am Suhas Hegde, the Tech Community Programs Manager. Thanks all for joining us. So as you know, Concordium is a public permissionless privacy protecting blockchain. We have a unique ID feature as well. Um, as we know, as the internet is evolving, the identity part of is becoming a part of daily life, and hence Concordium wants to focus on that because you'll see in the coming few slides as to why it's so important. So Concordium is heavily research-based and industry-oriented. It's taken an industry-oriented approach. So there is a Concordium tech team, which consists of many pioneers in the industry. And also there's a Concordium internal science team, which is mainly from the Blockchain Research Institute at Cobra. And also we have scientific partners, which are many universities. So there's a lot of research going on for the past few years. And everything is, validated, scientifically checked and validated. And we wanted to take this approach because we saw that in the blockchain world, people were trying to raise money first and then build products. But we wanted to take a different approach. We wanted to focus heavily on research, validate the scientific research, and then build a product and then give it to everyone so that we have usable products. Hence this approach. So some of the features. So we have many different features, and they have its own advantages as well. So one of this being the identity primitive at the protocol level. So this is mainly done to preserve anonymity and unlinkability. So the ID feature is basically helping you with the identity verification, but then that does not mean that your ID is exposed to malicious actors or possible identity thefts and things like that, because we know that lately there has been a lot of identity thefts, and that's a big problem. So this is done in a very secure way using zero knowledge proofs. And we also focus on regulatory compliance. We are regulatory compliant by design, which basically means that if you have a court order and only then the identity is revealed. Until then, it still remains private. The main reason behind this regulatory compliance is because any sort of an enterprise needs to be regulatory compliant in any jurisdiction they work with. So this is one of the focus, because as we move into a world which is full of IoT and everything's connected to the internet, but then with that also comes great responsibility, and regulation is an important part of that. We can see that the blockchain and crypto world has been facing a lot of heat when it comes to regulatory compliance. So the only way is to have complete compliance and no contamination at all. That's one of the founding visions of our founding fathers, Lars. So also we have fast and secure finality layer. So there's always a trade-off between finality and the speed. So we thought, why not have the best of the both worlds? And we have gone with the unique approach that we do follow. And also the uptime, we want to have a public blockchain. So it needs to be decentralized, and also any sort of transaction made needs to be, uh, reliable. You cannot have transactions that are being dropped off or that are not finalizing fast. If you've been using the networks lately, you can notice, especially networks like Ethereum, which is taking quite a lot of gas fees or taking a lot of time to confirm. So scalability is an important factor, and this approach really helps with fast finality. And of course, energy efficient proof of stake mechanism is our way to go about it. We all know that proof of work is very energy intensive. So we want to be as friendly as possible to the environment, and it has its own advantages. And hence we've gone with this proof of stake mechanism. So, so let's speak a little bit about our ID-based permissionless, feature. So anyone can join a public blockchain, but then they have many drawbacks, of course, to everything there's a drawback, and proof of work, especially, we've been seeing lately that it's having a lot of energy issues, instances where it's taking up, a lot of energy compared to certain nation states as well. And also privacy and security is super important, right? So the Concordium is building on the advantages of existing blockchains, but it also fixes the drawbacks with the addition of certain features like POS and regulatory compliance for the finalization to provide finalization as a service. Also, we also support private and permissioned blockchains. So one of the advantages is you can build on top of Concordium, and you can have certain private blockchains as well. And it can still use the finalization features of Concordium. So you get the best of both worlds, and you don't have to really worry about your finalization layer or things like that. And our consensus mechanism. So, like I mentioned earlier, two-layer consensus mechanism. It's basically it combines the Nakamoto-style blockchain with a Byzantine fault-tolerant finalization layer. We chose this mainly because we wanted it to be fast, secure, and also reliable for transactions. I won't go too deep into this right now because it's a very lengthy subject. It's also very beautifully explained in the white paper and also by Professor Jesper. So you can go through that when you have more time. Um, so, um, so some of the tools that Concordium has, we have a wallet app. If you have participated in the testnet, you'll be familiar with it. And also, we have Rust-based smart contract support, which compiles to WebAssembly. So the Rust part is going to be explained more in detail by my colleague Ernest. Yes. So fast and scalable. So when you speak about you want fast and scalable transactions, right? Now, given two layers, Concordium wants to achieve this without any compromise in the speed as well as the security. So the reason why I'm explaining these things is because it's very essential we understand the kind of network we're dealing with. As you know, Concordium wants to be an enterprise blockchain. The word enterprise has been loosely thrown around a lot in the past, but there are hardly any few blockchains which actually achieve enterprise level scalability. Hence, Concordium did a lot of research on it. We have close to 30 plus research papers which have been published. And this has been done so that we can accommodate enterprises, and this we feel is possible by the two-layer approach. So we also have high transactions per second, which is very essential for businesses because when you operate on a global scale, you need to handle various transactions, and you can't have things like double spending, which is currently possible on popular networks like Visa and MasterCard. Our testnet, by the way, we achieved close to, I think, 2000 TPS, somewhere between 1000 to 2000 TPS when we were stress testing the network. Of course, this is going to improve on the mainnet with features like sharding. So we're really excited about it. Our mainnet release sometime during early Q2. And transactions in the Concordium platform are finalized and immutable within a very short period of time without relying on creation of subsequent blocks. So this is again one of the unique features of the two-layer approach. And we also use the novel sharding mechanism, which is of course in tandem with our finality layer. And we can also coordinate with a number of sub blockchains in parallel, so that way it is much more faster than a standalone blockchain. And as we move in the future, I think all public blockchains need to exist. There is no one single blockchain which is going to rule. But then also that also means that we need to have the right kind of infrastructure, and Concordium can support that. So if you're another blockchain, you can still run on Concordium and use Concordium's finality feature and still achieve the same kind of results. So we're also cost-effective and secure. Proof of stake mechanism coupled with the community BFT consensus ensures resource efficiency as well as secure transactions, even under adverse conditions. Again, it's tried and tested. So yeah. So I'll just play a short video here, which explains the different layers. Right. So you can see here that these are the different layers. Sorry about that. Yeah, so these are the different layers. There's the internet at the base, and then there's a network layer, which has, which consists of the peer-to-peer layer and also the catch-up. And then, sorry. Let me just wait for that to fully play out so that I can. Yes. So the consensus layer, you can see, consists of sharding, finality layer, and also the Nakamoto style consensus. And then on top of that is the execution layer and also the ID layer. And then, of course, we have the APIs through which you can interact with various different use cases. All right. So here, compliance and privacy. So a user's identity is stored off-chain and remains private, which means we don't store any sort of identity. Basically, all your data is fully secure. Even Concordium doesn't actually read the data. So it's 100% private. And unless it is requested by a court order or by legal channels, your identity remains private. So you have the advantage of privacy as well. Also, it's designed for global operations, such that it is compliant with local regulations. And also, it's very important to understand that Concordium is the only public blockchain which is permissionless blockchain, but also compliant with regulations. The reason why I stress so much in compliance is because 2021 is all about compliance. Now we are seeing record amounts of volumes on exchanges like Uniswap and things like that. But then also there is a growing concern by the governments regarding compliance, KYC, AML, things like that. So with our unique ID feature, I think we can fix this. We can still have decentralized exchanges and things like that, but also fully compliant. So this way, there is no way that they can stop this world of innovation. So we sort of complement the blockchain world, but also make sure that we are 100% compliant. So if you're a developer, you need to understand these features so that you can start thinking on innovative lines as to the kind of applications that can be built on Concordium. So yeah, coming back to on-chain identity system. So every user on the Concordium network is ID verified by independent third parties. So the independent third parties can be third parties of your country, which you trust. It could be identity verifiers and things like that. So currently we have, if you've participated in the testnet, you know that Notabene is one of the identity verifiers as well. And as I mentioned earlier, we use zero knowledge proofs, basically where we provide the ID, and you don't have to actually reveal your age and things like that, but you can actually interact using all functionalities. And identity systems can be utilized by businesses and persons for all kinds of devices and products. again, we are seeing a world which is more connected, which means that there are legal repercussions with respect to the IoT devices you use and things like that. And cybersecurity being such a huge concern, I think this ID system really plays an important role. So you can, just like all our computers have Mac IDs and things like that, I think eventually everyone will need to have IDs. Though I know that it sounds quite far-fetched, but it's pretty much a reality these days. And also, every transaction is cryptographically linked to the verified ID of the user, but it's undisclosed. So that's an important thing. Um, uh, we all know that as every year passes, there's a lot of surveillance and things like that. Surveillance does not necessarily mean that it needs to come at the cost of privacy, and that's exactly what Concordium wants to make sure. We make sure that your stuff remains private, especially your financial transactions, because that's super important. In the ubiquitous world that we currently live in. And also user can disclose what things they want to disclose, so it's fully flexible. We don't force you to disclose certain things. And also you can decide whether you want to stay encrypted or you want to publicize the elements on the ID chain. And also account policies are very flexible. So yeah. um, So the benefits for business applications, ton of business applications here. As a developer, it's really important to understand and think and dream about the kind of applications that can be built. Because end of the day, you never know. Someone from this session may be helping us build some cool applications for an enterprise. We've been having a lot of interest from a lot of enterprises to explore different blockchain solutions. And also Concordium provides white label solutions, which means that say you're a business and you want to build an application, you won't even realize that the underlying blockchain is Concordium. We provide white label solutions. So some of the applications, let me not get into too much of the details because it's going to take a long time. So identity at the protocol level, again, it's an important feature. And also fast, secure, and immutable consensus and finality at scale. This can be, an important feature for things like exchanges and settlement of assets, digital assets, things like that. Also, cost effective. Yes, this is again an important point to remember because I think last time I spent $150 for just a transaction in the Ethereum network. I know we keep hearing things like, yeah, the layer two is coming and things like that, but then the business world does not want to wait. We want the businesses want to use usable blockchains, and for that, it needs to be cost effective, and also we need to have stable transaction fees. Again, an important point of GTU, which is the native token of Concordium. And of course, energy efficient. We don't want to run a lot of miners, spend a lot of like energy on that. But also we are not compromising on the security. And also we use WebAssembly and Rust. Again, Rust is very important. Ernest is going to speak more about it in the coming few slides. And WebAssembly, as you know, is which means that it's open for all developers. Again, finality layer and also regulatory compliance, like I mentioned earlier. So these are some of the benefits for businesses. If you see that, if you combine these things, it's really easy for businesses to, set up businesses and explore new jurisdictions because all these features packed will help businesses just use Concordium as a plug and play, a blockchain as a service solution. So yeah, potential use cases. So static registry, smart contracts, identity, dynamic registry. When we say dynamic registry, it could be for things like fractional investing and drug supply chain, things like that. So the millennial generation, they believe in they don't believe in owning things. Rather, that's why we see applications like Uber and things like that, which are more of ride sharing applications. I think it's going to be more popular in the future as well. So stuff like that is going to be very useful. And also stablecoin. Again, if you're familiar with things like USDT, there's always that debate about the validity of um, the regulatory compliance and things like that. So since we'll be regulatory compliant and also we'll be having the ID, it becomes easy to support stable coins. So we could probably support like all the stable coins. It could be nation state coins as well. So that way it becomes more easier and helps people access blockchain and crypto more easily. We could also use it for voting, ID records, insurance payouts, things like that. Decentralized exchanges could be another application. Again, land title, food safety, IP management. I mean, the applications are plenty. I hope that a lot of developers can start thinking more innovative. I believe that scalability is not the most important thing because a lot of blockchains are trying to solve it, but how it's being solved, that is the most important. And for that, you need to not have any regulatory hurdles, and also, our unique consensus mechanism helps just with that. So hope we can see a lot of developers coming and building on top of Concordium. So broad distribution model is basically, like I mentioned earlier, we have white label solutions as well. Basically, it can be used by different blockchains or different companies, enterprises, and also finalization as a service for private shards. So this is again very unique. If you are another blockchain and want to utilize the consensus mechanism of Concordium, you're welcome. We are a public, open blockchain, so you're always welcome. And of course, we'll also have smart contract boutiques and things like that. We plan to nurture a huge initiative for the developers. You can expect that sometime next month. We'll speak about it later as well. So it's called the DevX initiative. So we hope a lot of Elon Musk's and Steve Jobs and the most Vitalik Buterins to come out of this initiative. We'll be launching it next month. We'll make a lot of noise about it. You'll hear about it as well. So watch out for that. So yeah, that's it. This was a brief introduction about the kind of possibilities with respect to the Concordium blockchain. I know it wasn't the most technical presentation, but then always it's important to understand the philosophy, where we're coming from, why we need this blockchain. Because if we don't understand that, it's you just end up thinking, oh, okay, it's just a corporate blockchain or things like that. So it's really important to understand where we're coming from and why we are doing what we want to do. So now I think over to my friend Ernest, who will give you an introduction to Rust and the tooling available and how you can get started. Ernest, are you there?
Yes, yes, yeah. Thank you very much, Suhas. Thank you, and
Yeah.
thanks for the insights as well. But it's really important to get the background and to get some context before leading into things. So now let's get to the fun stuff now. Okay.
Yeah.
um, my name's Ernest. I am the community lead for the Rust London user group. We're the largest Rust community in Europe, and we're the second largest after San Francisco. I'm also the developer evangelist, developer relations, Rust advocate for Concordium as well. So I'm the bridge between the Rust ecosystem and Concordium. Um, I coming into Concordium um, very recently, I was actually really impressed by how much they've done with the Rust programming language. And what I want to share with you or with the rest of this presentation is a brief introduction to Rust as a programming language and why Rust is great for uh, smart contracts in particular. And then we'll get into a little bit of tooling. I'll just give you a very quick primer as to how to get started with Rust. And then I'll share some resources for you, all of you to go off and kind of start your journey with Rust and explore all that's available to you through Concordium and just the general Rust ecosystem. So are my slides up, Suhas? I just want to see my section of the slides now.
Yes. Do you want me to share it or you?
Yes, yes, yeah, yeah. If you could share it for me and go through them. Thank you.
Sure thing. Just give me a moment.
No worries.
Yes.
Thank you. Okay, so Rust. If you haven't heard of the Rust programming language before, it is a systems programming language. I like to describe it as a mixed paradigm language. So Rust is a language that has many different influences from its past, and it has many different components to it. So some people, and it's still debated today, is Rust a procedural programming language? Is it a functional programming language? Is it a object-oriented programming language? It's all of them in a sense. It has features and it has imprints from all of these different programming paradigms. So there are functional elements of Rust like closures. There are object-oriented type things in the language like traits and structs. And there are also, it's also a procedural language at heart. So there are many different aspects of Rust that are taken from different programming languages. And that's by the nature of how it evolved and how the community developed the language. One of the most powerful features is its generic aspect as well. So generics are very, very important with Rust and a very powerful part of Rust as well. So uh, Rust began its life at Mozilla. So it was a language developed by Graydon Hall, who was trying to solve some of the memory issues that was occurring with the Firefox C++ code base. So Rust as a programming language, its core ethos is always to be fast and to be safe. It has at its ground level an, a USP of enabling you to have type safety and memory management discipline. So there are things that you just don't have to worry about with Rust when it comes to memory management, when it comes to having to deal with null pointers and seg faults and things like that. Because of the ownership and borrowing model, which we'll get into a little bit more, you just don't have to worry about these things. And that makes you as a programmer so much more liberated. You know, you just don't have to have that overhead of thinking about what's going on with the stack in the heap. Um, the memory isn't abstracted away from you because Rust is a low level language. That's where it gets its speed from. And in benchmarking, Rust sits in between C and C++ for its speed. So memory management isn't abstracted away from you like other languages, but it's made safer through the ownership and borrowing model. So Rust came about and hit its first stable version in 2015. So it began its life in 2009 and was a very experimental language all through those years. There were loads of different features that were added and removed in that time. For example, many people may not realize um, that Rust had a garbage collector when it was first being developed. So it did have a GC like other languages, but that was taken out. And when the ownership and borrowing model came, that's what made the language fast and safe. There were other features that were just borrowed from other languages and tried out, but were never really implemented and kept. Because Rust, again, is an evolving language. It's always moving, it's always going fast. The compiler is a new version of the compiler is released every 6 weeks. So you'll always be seeing new features, new ideas being implemented into the language at its core. Okay, yes, the next slide, please. Okay, so Rust and Concordium and Rust for smart contracts. There are a number of blockchain uh, projects that are implementing Rust at both the protocol level and at the application level with the smart contracts. And there's a reason for that. There's a reason why Rust is so popular in blockchain. Um, a number of projects, just like, yeah, next slide, please. Number of projects like ETH 2.0 is being implemented in Rust, meaning the rollups, the optimistic rollup application implementation, sorry, that they want to bring about is being implemented in Rust. Near Protocol, they use Rust for their smart contracts. Concordium, of course, uses Rust at both the protocol layer and as its smart contract language. Polkadot have the substrate implementation. That's where you're able to build parachains, both built in Rust. And Nervos is another blockchain that has Rust at its protocol layer as well. All of these different projects are using Rust because of the memory safety. The tooling, the memory, the memory safety model and the discipline that it enforces allows you to, um, again, not even worry about the computational accuracy of your cryptography, because you know that at its core, because of the memory safety that you have by default, it's memory safe by default. You know that that what you're implementing won't crash in many instances. Next slide, please. Can I have the next? Yes. So in terms of, again, why use Rust, the type system gives you an expressive, strongly typed system, which still allows you to have type inference, like a language like JavaScript or Python, but at the lowest level, you know that you're having a type that's implemented, and you know that it's a strongly typed language. So again, that ensures that anything that you're writing will be compiled with the right type. And any faults with your type, you find at compile time and not at runtime. Again, that's the big USP of the Rust programming language. All of these types of faults, all these types of errors you get at compile time and not at runtime. WASM, WebAssembly, which is the execution layer for the Concordium blockchain. Um, and that's why they chose Rust as the smart contract language um, from the onset. It WASM is seen as the next big thing for both cloud computing and blockchain as well. And what you get from Rust is the best tooling that you can find for any of the WASM targets. So WASM is a binary file format, which allows you to compile different code bases into one type of binary file format that you can execute. And the tooling that you get from Rust, things like WASM Pack, um, which is a suite of different tools that allow you to compile your Rust down into WASM, is something that has been very popular and is what really makes Rust stand out over other languages like TypeScript and C++ and C when it comes to actually using WASM as an execution layer. Okay, so if you want to get started with Rust, you can go to rust-lang.org and you will be prompted to download um, the compiler and cargo and the standard library. That will be your tool chain. That's the basics of the Rust tool chain. Rust is available for Windows, Linux, and you can install it on WSL as well if you prefer to do that. Um, and again, as I stated before, you get a new Rust compiler every 6 weeks. The way you install Rust is through a tool using RustUp, and that allows you to also install other tools that are really, really helpful and quite unique to any other programming language. We'll look at some of those in a minute, things like Clippy um, and things like Miri, which are optional tools, but your which is an LLVM interface written in Rust, Cargo, and you also get the standard library as well. Concordium have a subset of Cargo, which is called Cargo Concordium, and that's what you use. That's what you use for actually compiling and building smart contracts. Someone just asked if I can show you how to write a smart contract in Rust. That we didn't get that brief, and tech demos are always very dangerous. So I think I would love to, but that's a little bit beyond the scope of this. I think this was just meant to be a general introduction. Am I right, Anthony? We can't get into some code now because it's kind of like,
you can get into code if I mean
really, because okay, well, look, what we'll do is I'll continue with this, and then we'll see what we have time for afterwards.
Sure.
If we can show some of what
we could probably have a separate session for that, probably in the next session.
We might be able to walk through some of like the piggy bank tutorial and stuff like that as well. So I'll show some of the basics. But yeah, Cargo Concordium is basically Concordium's subset of the Rust standard library that allows you to write smart contracts using Rust. That's one of the interesting aspects of using Rust as a programming language for smart contracts on blockchain, because it's a massive language. It's used in many different domains, and there are only certain aspects that are really kind of pertinent and applicable to smart contracts. So some of that has to be kind of abstracted out and extracted out more so, and allowed to be used for smart contract development specifically. And that's something that's coming in the future with Concordium as well. So next slide, please. Right, so just with the fundamentals, a crate is a library, same thing. That's what libraries are called in Rust, and a package of crates is compiled together using Cargo. What you do when you have, sorry, I've just lost my train of thought. Sorry, what you do when you have Cargo Concordium is you're using the tooling from the Rust ecosystem for your smart contract. So that's one of the key benefits that I noted down, is that you don't have to rewrite the whole ecosystem again. When you find some other projects that are doing everything from scratch, they tend to suffer in the tooling aspect because they have to rebuild everything from scratch. But with Concordium, you have Cargo there, where you're able to have a compilation target and you're able to have a consistent compilation process each time, because it uses Cargo, it uses all the tooling that's already there, which is being used across the Rust ecosystem. So that's what really makes coding and creating smart contracts in Rust with Concordium so much more easier. The library, the standard library, is linked in to Cargo Concordium by default, but you can switch that on and off using no STD as a target, as a compilation target. But having the standard library allows you to utilize everything that's being built by the Rust ecosystem at large. So that's what is, again, another really, really big benefit. And I'm going to keep emphasizing that because it's really important to share that. That you just don't have to think about certain things. You don't have to worry about like things not being there, because it's not just about blockchain. It's being built out for the whole ecosystem. And Concordium takes advantage of that in a very, very good way. Next slide, please. Right, this is where we come to some of the basics of the tooling. Cargo, again, is the package manager for every Rust code base, including everything that you would build with Concordium. It was actually something I don't want to say stolen, but we'll say borrowed, because that's a Rust term. It was borrowed from Node. So Node, and anyone who's programmed with NPM knows that that's the package manager for the Node ecosystem, the Node programming ecosystem. And that's the beautiful thing about Rust. There are so many different people from so many different language communities who came in and were like, look, let's bring some of the best things from our communities into this language. And that's where you get something like Cargo, which is a package manager that allows you to have a consistent, repeatable build process. You don't have to worry about make files. You don't have to worry about like build scripts or anything else, because Cargo automates that process for you. And that's something that was taken directly from Node.js or Node, or yeah, Node in general. Next slide, please. So here are some of the tools and resources and some things that you can use to get yourself started with with Rust in general. So these are some of the other tools that I mentioned: Clippy, Miri, and Rust Analysis. Clippy is a add-on to the Rust toolchain that actually corrects your code for you. It is a linter, basically, and it also gives you contextual hints as to how to optimize your code. So one of the main things that I learned as a beginner, still learning the language myself, still building and growing and learning everything about the language, is that the compiler is your friend. The compile errors are there to help you because they're really, really thought through. So it's not like a lot of other languages where you don't really understand why it doesn't work, and then you have to, play around. And this will give you very clear and very expressive compile errors because it wants to help you. The compiler wants you to optimize your code. And that's another big reason why you get so many of your important errors at compile time and not at runtime, because at runtime, it's already too late. Whereas if you have the understanding of what you need to do to optimize your code to make things better, that's what allows you to just get things done better the first time around, or not having to constantly go over things again and again. That's one of the things that's said about Rust. It takes longer to write code in Rust, but it takes a shorter time to write good code in Rust. So even the learning curve is steeper with Rust as a language, but once you get to a certain point with it, you'll know that you're able to write better code faster than just writing any kind of code really quickly. Because of tools like, again, Clippy and Miri. Miri is an interpreter. It's an interpreter tool that allows you to catch undefined behavior at compile time. And there are extensions being made to Miri, some interesting announcements coming from Concordium, which will involve formal verification and some other really, really important things that are really going to make the language, again, more safe for you. Safety isn't optional with Rust. Safety is, again, by default. And all of these things really take the load off of the programmer to allow you to be more creative and more expressive. Rust Analysis is just the analysis tool to check through your code, basically. It adds in a lot of, again, context again, with undefined behavior. But these are tooling that really come into their own light when you need them. When you're really writing complex smart contracts and things like that, and you don't understand where this fault's coming from, you have all these tools available to you to get things right not the first time, because that's never really possible, but you don't have to constantly go over the same faults again and again, because it's going to give you more context than you even need to an extent. Resources, the Rust Playground. So if you ever seen the Playground website, it's like a web ID which allows you to try out syntax, get used to some of the tooling, get used to some of the other elements of the ecosystem. There is an extension to the Rust Playground, which is being written by a community member called explain.rs, which actually explains the syntax to you. So you can paste in some code, hover over your function definitions, hover over your data structures, and it will explain it back to you. It will say, this is this is that, this is a function that takes in this input and returns this. So that comes into its own when you are working with someone else and they give you a chunk of Rust code and you want to figure it out and you're still not comfortable with the syntax of the language. You can paste it into explain.rs and it will run through and explain and give you context and give you an understanding of the code base. Cheat.rs is a cheat sheet. It's one of the best cheat sheets I've seen for any programming language. It really gives you a lot of granular breakdown as to what you need to do for what. If you want to extract out code to, you know, for, again, data structures, and you don't know the pattern, the pattern to use, but the most optimized pattern to use, it will just be there in cheat.rs. So please check all of those resources out. And for learning, these are things that I've used in the past before. The Rust book, the famous Rust book. This was written by Steve Klabnik and, oh, I'm forgetting the name now. But this is basically the documentation and the best primer for the Rust programming language. It gives you a breakdown of all of the different features of the language, and it gives you a very broad-based, clear, simple explanation of some of the core components to get you up and running. Exercism is a website that has exercises that you can run through. It's not just for Rust. There are loads of different programming languages, but they have a really good Rust track that allows you to work through some of the fundamental exercises that you would get, and you'd have to kind of sift through a ton of different websites to find all of these different kind of exercises to drill and to get used to some of the features of the language. Exercism collects them all in one place. And the really, really good thing here is that they have mentorship. So you submit an exercise to a community of mentors who will give you feedback, right? So they'll give you feedback on how you've written this little for loop, and they'll tell you this was good, but you know, you could do this and tweak this, and it's all done in a community collaborative way. So Exorcism is a really, really great way. They have interview questions and exercises used in coding interviews in there as well. So that's a great way to practice and drill and really work through thinking in an idiomatic Rust sort of way. There's also Rustlings, which is another famous Rust tutorial series from GitHub. Again, it walks you through different types of exercises, but for the core structural foundational aspects of the language, like structs, you'll understand what traits are and how they're so similar to interfaces in Java, for example. All of this you work through with a really nice methodical way. It's always being updated. There are always new commits being made and new exercises being added to Rustlings. There's also Rust by example, and a really good Udemy course by Nathan Stocks on Rust, and Concordium. Concordium is going to have a suite of Rust learning materials that will be out there free to anybody to use to learn how to create smart contracts, and also to really get bootstrapped with the language. So there are some really exciting things coming with how Rust is going to, with how Concordium is going to build out and really share what they want to share with, you know, everyone in regards to Rust. So I'm really excited for that. I think there's lots more to come with what Concordium are doing. Right, community. This is something that I'm really passionate about. This is something that has been really important for me even sticking around in the Rust community, because it is the key to the success. As I said before, Rust is a difficult language to get started with because, you know, there are certain things and certain concepts that are really difficult to grasp, especially the ownership and borrowing model. Once you get that, once you really understand ownership and borrowing, then the rest of the language, you know, you're away. You're really, really going to be on a flying start with it. And having a community, having such a broad base of different places where you can interact with people who are just really nice overall. Rust being quite a new language, it hasn't got that kind of overhead or baggage that comes with other languages. And there's a reason why it's been voted the most loved programming language on Stack Overflow 5 years in a row. That's not just because it's fast. That's not just because it's safe. It's because it has a really vibrant community. The Concordium Discord is always really fun. You know, you have lots of people talking about Rust in there because it's so important and it's at the heart of the blockchain project itself. You then have the Rust Discord in general, where you have, you know, so many different places where you can hang out and learn and observe. And what's interesting is a lot of the rock stars, quote unquote, are accessible. You know, you can ask questions to people who are building out and adding features to the standard library because they'll be in the Discord and they'll be accessible. So this is a really, really important part and a really, really important thing. You have the conferences as well, Rustfest, RustConf, the upcoming Cloud Native Rust Days, Rust Lab, Rusty Days as well. There are a bunch of really, really, really cool conferences, all online now because of, you know, everything that we're going through. And you're able to kind of, again, interact with people and learn from people and see what's coming, some of the new advancements, some of the interesting things people are working on, you know, and it really opens up the possibility. I know Concordium are going to be speaking at a lot of these events in the coming months. So you're going to see a lot more of that. And the working groups, Rust as a programming language focuses on empowering everyone to be able to contribute to the language. It doesn't matter if you're a newbie still trying to learn the language or someone who's been there since 2011. They want people to contribute to the language. They want people to feel empowered to contribute to the language, which is what, again, Concordium have been able to do by even having the subset of the standard library that they do have. You have different working groups where discussions are happening. People are trying to fill in gaps in the ecosystem. They're trying to work out what's missing, and they're open and they're transparent, and they are there for people to be involved and be in the mix with. So yeah, that is something that is really important and really, really empowering for me personally as well. So that is Rust, and that is the Rust community, and that is what Concordium are doing with Rust. Thank you very much, Sue. I think that's the end of my slides, right?
Yeah. Thanks.
Right. So you know what? I feel like I have to open up my IDE now. You know, I don't want to leave everyone without at least sharing some code. This was completely unplanned, but I'm gonna open up my IDE and I'm just gonna like basically show some basic things with like what I've been talking about. Bear with me 1 minute because this is completely impromptu. So just hang on and I'll get myself sorted out. We've got like 5 minutes.
I see a lot of people asking questions regarding, code with the blockchain. So we're going to have, so the reason why we sort of went with this is because, we wanted you to understand what you're building upon and also have a fundamental understanding of the Rust ecosystem and also how you're going to be coding on Rust and how you can utilize that in Concordium. We will definitely have dedicated sessions. In the coming few sessions, it's going to be completely technical. We're probably going to get our chief architect, Alesh, to come and, play around a little bit with the code. So yeah, Alesh, if you
let
want
me just, okay, I'm going to share my screen. All right, so.
Yes, there are. I also see a question asking if there's more technical events coming up. Yes, definitely. You should also come drop by our Discord. A lot of discussions are happening there. We currently have the smart contract missions as well, for which is a part of the testnet 4.
All right. So this is me halfway, well, yeah, halfway through one of these sample smart contracts that Concordium gives you, written purely in Rust. So I'll take you through cargo and a little bit of what I've done here, and then in the next couple of minutes, just to give you a little bit of an understanding. So this is a piggy bank smart contract. So it's a smart contract that enables anyone on the network to place GTU, which is the native token of Concordium, into the piggy bank, but only the owner can smash the piggy bank and release the coins, right? So what you're doing here is you have to create 3 different types of functions that allow the GTU to be held inside the smart contract itself. And you need to have a feature, you have to build a function that allows the piggy bank to be smashed. And that can only be done by the owner of the smart contract. So you have to set the state of that as well. Now, the syntax, starting straight from the beginning, this is a Rust package. And with every Rust package, you start with what's called your cargo TOML. So TOML is a file format, stands for Tom's Obvious Markup Language. And TOML is, your cargo TOML is your manifest. Again, this is something that was borrowed from other programming languages like JavaScript. So if you've ever seen like your JSON manifest in JavaScript, where you add dependencies and things like that, this was inspired by that. So whenever you're starting a new project, you start with your cargo TOML manifest, which is where you declare your dependencies, you declare the type of library binary that you want. This is basically using a cdylib and rdylib. It's basically like a DLL, a dynamically linked library. You're telling the compiler to give you a DLL-like target at the end of compilation. And just, you know, the other general information with your package. So Rust comes in editions, and the editions are marked down by year. The latest edition is 2018, but we're going to have a new edition soon, I think in 2023, or there might actually even be Rust 2020 as well. I'll have to double check that, but basically Rust comes in editions. If you're familiar with C++, this is similar to having C++11, C++14, C++17, and C++2020. It's the same sort of thing. So new features and new, it's like an epoch of the language itself. You have the version of your actual application, the name of your application, and who has written it. This is your cargo TOML manifest. Your source code is, usually you have a main.rs file, but you can also have a lib.rs file. It's similar to having a library file and a main file in other languages. And here, again, this is a module. So Rust uses a modular system for its packages. Inside the file here, Concordium smart contracts, Piggy bank is my crate. Piggy bank is my package. And lib.rs is the root of that package. So whenever any other file I'll create, the entry point for the compiler will be the lib.rs, because it's the root of that, crate. I hope that makes sense. I hope this is turning into a tutorial, and I wasn't planning that. I've gone a little bit over time, but I'm gonna run through this a little bit more. Coming back to the actually writing the code and writing the smart contract itself, you import the standard library here using the use keyword, And what I'm doing here is I'm importing the Concordium standard library. And again, if you can see here, just by me hovering over, it gives me an explanation inside the documentation right there. So if I'm unsure of what the package or the crate that I'm importing is doing, I can hover over it and it will read it to me. This is coming directly from the documentation itself because it's linked into your code through other tooling like docs.rs. Right here, I am creating an enum for the state of the piggy bank. So the piggy bank can only be two things. It can either be intact or it can be broken. And what I'm using for that is this is a procedural macro, but I don't want to get too much into that right now. I'm gonna have to cut this off here because I'm gonna get into it, and it's gonna get really it's gonna get fun and messy and interesting at the same time. The last thing I'll leave you with is this is what a function signature looks like. So just like many other sorts of function signatures that you'll see in Java or C++, you have a name, you have your inputs, and you have your outputs here. Here we're stating the output will be the piggy bank state because Rust is an expression-based language. And what we're using here is something called option and result. But again, I won't get into that now. That'll be something for another time. Thank you all so much for having me here and hearing me ramble about this programming language that I'm a fanboy of. I'm going to hand back to Anthony, right? And then we'll leave it from there.
Ernest, that was great. Thank you very much. Especially
no worries.
It was I enjoyed it, definitely.
Wait, you had me doing an impromptu like
do a little dance.
tutorial, like totally unplanned, but thank you all the same.
No, Ernest, thank you very much. Should we deal with any of the remaining questions? I know we're running over, guys, and some of you probably have places to be, things to see. Ernest, have you recorded any tutorials before? You're awesome.
No. Thank you very much for having said that. But well, watch this space. There's some stuff coming with Concordium. You never know. There's lots going on with Concordium with Rust. So they're going to be really doing some really fun stuff. You know, I know it's all enterprise, but it really is a fun project at heart. There's a lot of vibrance with the project, and there's a lot that they're trying to do. Thank you. I actually need to go because I'm actually hosting a meetup right now. I'm hosting our first Rust London meetup, so you're all welcome there as well. And yeah, again, this was really fun, and yeah, Concordium, like there's a lot to come with that project. So thank you all, and I hope to see you all soon again. Awesome. Thanks for having me.
Thanks, Ernest.
All right, take care.
Cheers. Bye. Let's just tidy up here then, Tues.
Yeah.
That we can't really do the technical questions. I'm looking for a platform with fast transactions and potential to build asset tokenization. Why is Concordium suited for this?
There are many different advantages for that. Again, it depends on the kind of asset you're building. If your asset needs fast finality, again, Concordium is a good choice. Again, it depends on the kind of application you're building eventually and what the asset is used for. So yes, it's suited. Yes, Concordium is definitely suitable for building such an asset. I think in the coming few sessions as well, we'll have tutorials especially for that.
Awesome.
Cool. Oh yeah, real estate has a lot of applications there because when you say real estate, it could mean a lot of things. Like it could be for rental sharing. It could be for many different things, and the Concordium ID definitely would help there. So ideally speaking, Concordium would probably be the best choice of blockchain, considering real estate involves a real life assets, again, which requires regulatory compliance and things like that.
Cool. Right, just see if we've missed anything. Cool. For those guys looking for a more technical event, I know this event was called Intro to Coding. So some of you were kind of a bit disappointed. I'm sure there'll be events kind of within the Concordium ecosystem moving forward on this, and there's certainly much to kind of find online. So do tend to stay in touch via their Discord. I'm sure Suez can post the links to that now, and their Twitter. And yeah, if you do want to kind of learn more in general about blockchain and join other events, kind of a more general nature, please do go to encodeclub.com. I'll paste the link now here and check us out. If you have anything. Suresh, I'm sure, is about to paste the links as well on the Concordium side. But thank you everyone for joining this evening and for listening to everything we have to say. Yeah, and please do stay in touch. Join the Discords, say good things. And yeah, Suresh, thank you again for your time this evening in explaining everything. Awesome. Well, thanks, guys. See you all very soon.